Hello and welcome back to another LeetCode.js video. This video we will be talking about the solution to reversing a linked list, a standard linked list problem where you are given a single input, the head of a singly linked list, reverse the list and return the reversed list. So the key to solving this problem is to instantiate three pointers. One denoting the previous list node, the next list node, and the current list node. So the current pointer will traverse the entire linked list, reaching the tail of the linked list. And we'll do this in a while loop where we finally return the previous node, which is previous to current. And in this example here, we see really the only thing that changes, this diagram is a little confusing because simply we just want to reverse the direction of these nodes. So that's how I would look at linked list problems like these, because the class list node has two attributes, one denoting the value of the list node and another attribute, the second attribute denoting the next node that this current node points to. So knowing this, we're first going to instantiate the three pointers. So the previous node would be null. We'll instantiate it as a null pointer because there is no previous node. In the case of, so then we'll instantiate the next node, which will be null as well. And finally, the current, which will of course set to the head. Next, we'll put in a while loop, checking that so long as current exists, is not undefined, so traversing the entire linked list. We want to do a couple of things, which is just to set the previous, next, and current. We have three pointers here. The reason being we need to we can't just swap out the nodes, because if we swap out the nodes, then we're not going to know what the next node is. So just swapping two, like 1 and 2, is not sufficient, because if we have a third element, then doing this will contain a cycle, and we won't know which we wouldn't have assigned the pointer correctly. So now that we have these pointers here, it follows by plain English that the next node will be the next node that current points to. The previous node, after we make the change to the current node, will be equal to the current node after current traverses to the next element. So then we set cur equal to the next element, and finally, we want to return the previous node because it exits if the current node does not exist. This will happen in the last iteration of the loop, setting next equal cur.next. If it is the tail end of the linked list, then it won't point to anything, so will be undefined. But previous will, of course, still be a list node. So that is why we're returning the previous node. And just like that, we'll submit. And I must have made a mistake in the while loop here. So I set next is equal to the current dot next. So let's take a look at this example again. So current is set to 1. Now current needs to be set to 2 because 2 needs to point back to the previous. So actually current.next should point to the previous element. Previous is still going to be set to current. That is okay in this while loop because in the next iteration, this next value will be the correct next value. So that's why we have 3 pointers, because one will now point or 2 will point to 1 and 1 will point to a null value as we want. But the current pointer will still traverse 3 because we didn't change current here. So current still goes where we want it to. So it looks like there's still an issue with how I'm setting up this while loop. Think for a moment. So I believe because we set current.next equal to prev, possibly putting that in front. Yeah, so this is a LeetCode easy problem, but it is confusing because of the list node definition that they use in JavaScript, in this JavaScript interpreter. But I'm gonna crack this problem. Just need to put everything in line and make sure that I'm doing what I should with the pointer. So previous, next, and current, that still stands. We'll have our undefined list element that now the head points to. The current element originally was pointing to 2, but now it's pointing to the previous. So now the next element should point to the current element. So next is equal to cur.next, okay, but next dot next should point to the current element, okay, and then the previous element is equal to the current element, because when we traverse the current node to here, the previous element is here. So now the previous element gets set to the current element. In the next iteration, current moves up to 3, and then we rewire 3 back to 2. So we do that by setting next.next equal to current. That's how we set it backwards. And then we set previous equal to current. And that should be our solution. Again, time limit exceeded. How much time do we have here? Plenty of time. So back to the drawing board. So we set next, in this case, to current.next. Previous element. Okay, so while current is not null, we set current is equal to previous. The previous pointer to the current element. Okay. And then, well, before we did that, we set next is equal to current.next. Okay. And now I think the problem is we're not setting the current node properly. So we set previous equal to current, but we're not actually doing anything with current. So I believe we just need to increment current to the next element, because next equals current.next. That's fine. So current is just our pointer that will simply just go from the head to the tail. There's nothing fancy about that. Only things that need to rewire is the next and the previous pointer. Okay. Still, time limit exceeded, meaning that we're not properly incrementing current. So I'm going to remove these first 3 lines because they're confusing. What we do know is that current should go from the front of the list to the end of the list. So that's okay. Now previous should be set to current after next has been set. So we said next is equal to current.next. Okay. And at the end, because next points to current.next, we'll set cur equal next. That's the same thing as incrementing. But now the next element should point to the current element. And we want to do this after setting, well, before, next on x equal to the current element. Now the previous element is going to be set to the current element, and then we increment current to the next element. Pointer, current, and next. So yeah, next on next should be set to current. Okay, so that's good. Next on next set to current. The next value should be instantiated at current.next, so that's okay. Okay, so these two lines are good. We're just setting the next element so long as current exists. Now the previous element after the previous element should now be current. Okay, the previous element now moves up to current, and the current should be set to next. So I don't see where the algorithm is failing at the moment. So I'm gonna run these test cases, see if we can get some more information. And time limit exceeds. So there must be some cycle that is happening. Current is equal to head. In the case where there's only one element, then previous gets set to current and we return previous. Yeah, so it should work for case number 3. Case 2, we'll just run it through. So 1 points to 2. The previous is set to null value, so previous is here, current is here, and the next is here. So next on next in this case should be set to current. Okay, next is equal to current dot next. Okay, and next on next is set to current. Now we want to increment current to next, and then the previous element should be current. So this isn't gonna work, but I'm gonna see if I can draw up another example. None of the test cases passes, so there's something wrong with my pointer instantiation. So next is set to current.next. Next.next is set to current. But now the issue is when we set current equal to next points back to current. So if there was another element, it would not node to traverse current to item number 3 in this case. So we want current to go to next. But then we want next, which is a different pointer, which is a different list node. So we can't just set current equal next. We should just call the next attribute. Let's see, there's a cycle here. Next, cur goes to next, and then next goes to cur. So maybe we have to do this at the very end. So let's just write out the state that we want. So at time 0, cur, so previous is set to null, current is set to 1, and next is also set to null. Okay. At the next step, t equals 1, p, the previous, should now be set to the current. The next should be set to current dot next, and the current dot next should be set to the previous, and then current set to next. Yeah, so that is the loop that we want. So while current, now the previous is equal to current, next is equal to current dot next is equal to previous, current equal next. And that hopefully doesn't give us another infinite loop, another cycle, but it's not indefinitely looping, and it's at least working for this case here. So maybe I have to rearrange setting previous equal to cur as the last step. Well, next can stay where that is. After current is set to next, that we want to do last. So previous should be equal to cur. That right there is our answer. So, a simple problem, but the trick is rewiring the pointers, because when we set one node next value to the previous node, then it loses track of where to go next. So the order that you're doing this is as follows. Like I said, this is the correct state of the program, but the only issue that I had um, just before I completed the problem was just not instantiating the pointers um, previous to current um, after setting next to previous. Yeah, that is obvious because otherwise next will just point to itself, because if the previous is current, then we set current.next equal to previous, which is equal to current, so current.next is equal to current. So there you go. That's reversing a linked list. Thank you.